Hello, I am Shafiqul Islam, a senior researcher at Blaking Institute of Technology. Our research team focuses on model-based design technique and modeling of manufacturing processes in sheet metal forming and other non-metallic composites and polymers. This presentation is on a recently concluded research project led by BTH titled Failure Prediction for Complex Load Cases in Sheet Metal Forming. With BTH, Rice, Volvo Cars, SSAB, Alfa Laval, Volvo Trucks, and Scania contributed to this Vinova-funded project, which was active between 2020 and early 2024. The project, in short, is called PREDICT. Here we worked on digital twin of metal forming mechanics and processes to improve finite element models and data models. Those can predict failure in sheet metal during forming. In typical forming process, flat metal sheets are deformed between forming dies. The models today can accurately simulate most of these processes. Thanks to finite element models using rigorous material characterization of excellent accuracy and process factors like friction. However, any failure in form part model is predicted using decade-old forming limit curve. This is a major bottleneck, resulting drawbacks like over-design or restricting adoption of more sustainable materials. Some examples of failure in manufacturing processes are nonlinear strain path, combined loading, crack happening at the edge while forming. Noticeably, these failure detections are poor with traditional forming limit curve in many cases. So Predict worked on achieving more accurate failure prediction in previously mentioned cases and suggesting process adjustment to prevent failure. Here is a study on nonlinear strain path affecting failure. The part failed during forming here, and the strain path in this black line, and it's obviously nonlinear. Current forming limit cannot predict this failure. This figure highlights the forming limit to be linear in nature. In Predict, we try to bypass this nonlinear effect by transforming this forming limit curve in other relevant measures. See the results in the linked publication. A major effort was put on developing experimental database that shows how nonlinear strain is affecting forming limit in several materials. Another study showed combined stretching and bending increases the forming limit, which is a favorable effect. The detail of the study again is published and can be read here. Edge formability is popularly measured by hole expansion test and measuring the hole expansion ratio. In this project Predict, we suggested improvement of this test method to reduce the variation of the experimental formability measure, which is hole expansion ratio. The variation in edge formability was also successfully modeled in finite element simulation as material property variation or process parameter variation. Again, the results are published and can be read. In Predict, we also contributed to advanced material calibration by using full strain field or advanced test specimen for calibration purposes. And in the project, we also proposed few methods for failure detection and theoretical prediction of failure. For details, we kindly refer to the publications here. Finally, in a data model case study, we looked into variation in material and process setting which are unavoidable. Simulation and measurement-based dataset was generated relating causes and effect of these variations in an artificial neural network. This study promises such models can be useful to suggest process parameter adjustment or preventive measures against failure. A list of publication related to Predict is here. So we invite you to visit. In conclusion, predict increase the failure prediction accuracy of finite element models and also recommended that machine learning models can be used for failure prevention in forming production. In future, such machine learning models can be put in action in the press line. The effort in simplifying and making the calibration process of material cheaper will be continued. Uncertainty quantification showed great possibility of doing non-deterministic finite element modeling of forming. Overall, the predict results adoption in the industry will need future work. Thank you for the interest. Summary of the predict study can be read in the project public report here.